Let us talk about this problem. We need to design two stacks in a single array. So you need to make a class that uses a single array of given capacity, and there should be two stacks implemented within the same array, right? So it should support the operations like push1, which adds an item to stack 1, push2, which adds an item to stack 2, pop1 to remove an item from stack 1, pop2 to remove an item from stack 2, size1 to tell how many items are currently there in stack 1, size2 to tell how many items are currently in stack 2. And we need to implement all these operations using this single array space. So one reason for such requirement can be cache friendliness, right? You want to use single space of contiguous location to implement two stacks so that there is a locality of reference, right? If you create two stacks, two different objects, they would be created in different locations, and if you are accessing both these stacks together, then there would not be locality of reference like this implementation. So that could be one reason for such requirement. So we mainly need to design this class. So if you're coming to this video, it's strongly recommended that you get a basic idea about structures and classes in C++ or class in Java. So class is used to create a user-defined data type. Class is a keyword in both C++ and Java, right? So we are creating a user-defined data type, and it's a collection of data and methods. So this is the data of the class. So whenever you create a variable of toStext type, that will have this data, right, which is part of this class, and you can apply those methods on those objects. This is Java style syntax, and if you want to create a dynamic size array in C++, then you need to use pointer, right? And this syntax is same in both C++ and Java, right? You can allocate memory to the pointer in C++. In C++, by default, things are private, right? So ideally, you want to keep the data as private and you want to keep the methods as public. So we need to add public here in C++ before we define the methods. This is constructor, and the idea of constructor is same in all the languages. It is called when an object is created in memory, right? So to create an object, we need to know the capacity of the array. So we pass capacity of the array as n, right? This creates an array and initialize the capacity. There are some more things that you will have to do. You will have to initialize top 1 of stack 1 and top 2 of stack 2. Those initializations are required. I'm leaving those for you. Right, so you would want to pause the video and then try this implementation yourself. So push1, again I'm leaving these implementations for you. And in the very simple implementation, I have mentioned the return type as void. So push operation might not be successful. When you are trying to add an item, it might happen this array is full or a stack is full. So in that case, your push1 should return false, and if it is able to successfully insert an item, then it should return true, right? So you might want to extend the implementation a bit to add boolean type here, return type here. Similarly, in the pop1 and pop2, instead of simply returning an integer, basic integer type, you might want to return an integer object in Java so that you can return null in Java, right? If you're not able to pop if the stack is empty. And in C++, you might want to return a pointer to an object or pointer to a variable so that you can return null if the stack is empty. Otherwise, you can return the integer variable. And if you wish to keep the C++ implementation very simple, don't want to use pointers, then you can keep the return type as void also, and you can keep integer, and you may exit from the code by writing a message stack underflow. But that's not a very good implementation. Ideally, we should have a return type proper, an object, right? And we should return null if the stack is empty. That's a better implementation. Size1 is simple. It's an integer value that you need to return. So first try basic implementation with void return type. Maybe you can have void here as well, right? Try to complete, then try to beautify the code yourself. So please pause this video and try to write down the complete class implementation yourself and try to see if it is working fine. You are able to create two stacks and you are able to use two stacks. Let us first talk about a naive solution to solve the problem. What we do in the naive solution, we simply divide the array from the middle point. If there are 10 elements in the array, then we keep 5 reserved for stack 1 and 5 reserved for stack 2, right? And we keep adding items from this side. Suppose you add 10 in the stack 1, then it will be added here, then 20 added here, then 30 here, then 40 here, and 40 here. Now if you pop an item, 50 will be removed, right? And if you add more items, you can't add more items. So this is the problem with this approach. See, after 5 items, if I want to add any more item to stack 1, I cannot add even if I have space in the array, because I fixed the size of stack 1 and stack 2, 5 elements, the maximum size of stack 2. 1 and stack 2. So that's the problem with this approach. Even if you have space left in the array, you can't add any more items in the stack 1. And that is why it is inefficient in terms of usage of space. Now please pause this video and try to think of an approach that works efficiently in terms of space and has big O of one-time complexity for all the operations. Let us now talk about idea for the efficient solution. The idea is to begin from both corners of the array. So we begin stack 1 from this side and stack 2 from this side. So we basically initialize top 1 as -1, right? The index before the first item, and top 2 as size of the array. If size of the array is 10, then top 2 is initialized as 10, right? Beyond the last index. So whenever we add an item, what we are going to do is, we are going to do first add an item say to stack 1, then we'll do top 1 plus plus, we'll add 1 to top 1, and then we'll add the item at the top 1 index. And if we are adding an item to stack 2, then we'll do top 2 equal to top 2 minus 1 or top 2 minus minus. And then we'll add an item at this index, at the index top 2. Right? Similarly, when you are removing an item, then you will do top 1 minus 1 and you will do top 2 plus 1. Right? And obviously, you need to ensure that these two, top 1 and top 2, they don't cross each other. Right? They don't go beyond each other. The best part about this implementation is you are using the same array and you are able to insert items even if there is a single slot available. See, here I have added 6 items to stack 1. In fact, I can add 10 items to stack 1 if the stack 2 is empty, right? There is no reserved space here. So now you have complete idea about the solution. Please pause this video and try to write down all the functions, complete class yourself. Here is implementation of the idea that we talked about. I have created a class 2stacks and the code here written is in Java. If you are programming in C++, you just need to make some minor changes. For example, in C++, when you create a class, all the members are private by default, right? In Java, there is default access specifier. So ideally, we should be having these members as private. So we should write public here in C++, right? In C++, you write public here before methods. Typically, that's how you do it. You define methods as public. So we need to add this public here, right? If you're programming in C++. Also in C++, if you want to create a dynamic sized array, you can use a pointer here, right? In Java, you can use the syntax, but in C++, I need to use something like *arr to create a pointer to create a dynamically allocated array. Most of the other syntax is similar in both C++ and Java, right? There are minor differences. In C++, you have bool keyword instead of boolean. Here again, you have bool keyword. Also in C++, in Java, you have a wrapper class integer. So if you are writing a pop function and if the stack is empty, then you can return null in Java. It's a clean implementation. And this integer x, int x will anyways be converted to integer. So if there is an item, you will get that item as an integer object. Otherwise, you will get null. If you want to implement similar functionality in C++, then you will have to return maybe a pointer, right? Pointer to an integer so that you can return null and you can return a pointer to the top member of the class of the array, right? Something like this you can implement. So these are the differences. Otherwise, rest of the code is same in C++ and Java. See, in C++, if you don't want to implement this pointer thing, you can, in the else part, you can print a message, stack underflow, and you can exit from the code. That's also something you can do. So the logic is going to be same, and most of the other stuff is same in both C++ and Java. Right, so let's now understand the logic that we have implemented here. We are creating an array and we have these member variables, capacity. Cap stands for capacity, which is size of the array, right? And top 1 is top of the stack 1, top 2 is top of the stack 2. We initialize capacity as input provided capacity, right? Which is the size of the array that we are going to create. And top 1 is initialized as -1 and top 2 is initialized as n. So if user creates 2 stacks where total array size is 5, then top 1 is going to be -1 on the left of the leftmost item and top 2 is going to be on the right of rightmost item. Basically, these are not valid indexes. They indicate that stacks are empty. Now, when you push an item, you are going to do increment in top 1, right? And you are going to, that's how you are going to implement push operation stack 1. If you do push in stack 2, then you are going to decrement top 2 because this stack is going to grow from this side. And in the pop operations, we are going to do opposite. If you are going to remove an item or pop an item from this stack, you will do top 1 minus minus. And if you are going to remove an item from this stack, you will do top2 plus plus, right? The only thing where people make mistakes is in this condition. How do you write a condition to ensure that these two stacks do not cross each other, right? So you will be pushing an item only when there is a slot available in the array. And how do you figure out if there is a slot available in the array? See, if I add one more item, say 20, it will come here, top 1 will become 1, then 30, you will make it top 2. So now you can add an item because top 1 is smaller than top 2 minus 1. Top 2 minus 1 is 3 and top 1 is 2. Now if you add one more item, this will become 3. And after that, you cannot add an item. So when top 1 plus 1 becomes top 2, at that moment, you cannot add an item, right? When top 1 is equal to top 2 minus 1. So this is the condition we check. If top 1 is smaller than top 2 minus 1, in those cases, you allow the push operation. And the beauty of this implementation is you never waste space. If there is a single space and you ask for push 1 or push 2, they both are allowed to do because they both are growing in opposite direction. So that's what we are doing here. We are checking for this condition and then the implementation is simple. We do top 1 plus plus, we add x to the top 1 and we return true if there is successful insertion. Right? If there is no slot available, then we return false to indicate that the insertion or the push was unsuccessful. Same thing we do in push 2. If there is a slot available in the array, if there is at least one slot available, we do top 2 minus minus and we return true. Right? So similar operations are pop 1 and pop 2. Size of implementation is simple. We simply do top 1 plus 1. If you look at this implementation, this is initially minus 1. So initially the size is 0. When you have it as 0, the size is 1, right? If you have it say 1, then size is going to be 2. And top 2, initially this is 5. So size of the stack 2 is 5 minus 5, 0. When it becomes 4, then you have 5 minus 4, 1 size. So we simply return capacity minus top 2 as size of the other array. So this is the implementation. Time complexity of every operation is clearly big O of 1 here. If you wish to refer C++ code, you can refer the link in the description of this video. There are some minor changes. With those changes, we can do C++ implementation as well.